chi-square goodness of fit test on a grade distribution problem. The grade distribution of a differential calculus class is shown in the table below. Using the expected distributions, do you have evidence to prove that the observed distribution fit the expected distribution? So we have 5 letter grades A, B, C, D, and F, and then I took a random sample of 500 students, or just think about this. You took a random sample, or in a class there are 500 students, 150 of them got an A, 190 of them got a C, 100 got a 190 of them got a B, 100 C, 40 D, and then 20 F. And then the expected distribution. So what is expected distribution? So let's say you are deciding to take someone's class. You look into the historical data. So let's say you are trying to take differential calculus or statistics. So you are looking at this professor's class. So based on the historical data, or based on a table, or based on what the professor claimed, usually 23% of the students got an A, 34% of the people got a B, so on and so forth. And then you are thinking, all right, so you want to get an A, right? So you take class, you want to get an A. So is 23% fair to you? So if yes, then you take this class. If the percentage of getting an A is like 2% or 5%, then that percent is so low that you don't want to take this class. So that's what the expected value means. So you just look into the data, look into the record to see if that sounds fair to you. Yes, then you take this class. No, you're thinking that, all right, so only like 5% of people can get an A. I won't be this 5%, so I will just take someone else's class. Okay, so that is expected distribution. And then to calculate the expected frequency, then that is equals to the sample size times each of the percentage. So for example, for letter grade A, you are taking 500 times 0.23, and then for B, you are taking 500 times the percentage, 34%. So just write this out. So you are taking 500 times 0.34, and then 500 times 0.20, and then 500 times 0.13, and then 500 times 0.10. So 23, 34, 20, 13, and 10. And then you calculate this. The first one is 115, and then this is 170. So we have 100, and we have a 65, and then we have a 50. So now the datas are ready. We will need the observed frequency and the expected frequency. So what kind of question you are trying to answer? You are trying to answer that does the observed fit the expected? Can we simplify the language a little bit? Does the observed frequency fit the expected frequency? So to me, when I was learning chi-square goodness of fit, so this goodness of fit to me is like wearing a shoes. So you are trying to buy a shoes and you want to try the shoes, right? So the observed frequency is your foot, and then the expected frequency is the shoes that you wanted to buy. So you put your feet in the shoes to see if that is a fit or not fit. So you want to try a shoes. The answer is either a fit or not fit. So for the null hypothesis, the H naught, we will just say fit. So for the null hypothesis, we will just say fit. Okay, fit, good. And then HA, the alternative hypothesis, which is the opposite, we will just say not fit. Okay, so let's put the fit and not fit in the context of this problem. So if you want to make this very simple, you can do this H naught. You can say the observed grade frequency. So the observed grade frequency, let's just call this FRQ, fit the expected grade frequency. So fit, that's the keyword, fit the expected grade frequency. And then the HA will be, you copy the same thing except you change the fit to do not fit. So the HA is the observed grade frequency do not fit the expected grade frequency. Right, so fit versus not fit. And then the next step, you proceed to calculating the chi-square test statistics. I know we use a calculator, right? We input the data and then we use our calculator. But other than teaching the calculator, I will also show you how to calculate that by hand. So let's move on to the calculator part. So now take out your graphing calculator. And then the first place that you have to go, follow my screenshot, is you have to hit the stat key. So once you hit the stat key, the first thing you see is edit, right? So in the edit menu, number one, that is edit, and then you click edit, you put observed in L1, expected in L2, okay? Be careful, don't make any mistakes. If you enter one number wrong, the entire problem is wrong. Observed in L1, expected in L2. If you want to clean up the old data, just hit the tap on the up arrow, so move the cursor to the top of L1 and L2, hit clear, and then hit enter, right? Move the cursor all the way up, and then hit clear, and then enter to clean up the entire column. After the data is done, move on to the test. So you will be hitting a stat key, and then you hit the right arrow to go to test, and then you go down until you see chi-square goodness of fit test. So second screenshot on the right, chi-square GOF test, goodness of fit. And then once you click goodness of fit, the next menu, pretty simple. So observed frequency in L1, expected frequency in L2, and then the degree of freedom. So we have 5 letter grade, -1. Always you take the total number of categories, -1. So 5 letter grades, -1. And then the color, pick any color you like. So once you hit calculate, you will see the chi-square test statistics and the p-value. All right. So in this problem, you have 40.620, right, for the chi-square statistic. How do you calculate this by hand? Still remember that back to the normal distribution, the z, the t, the proportion. You can just plug in the number to the formula to calculate, but how do we get the 40? How do we calculate the 40 by hand? So here is how. So let me switch to different color. So the formula is chi-square. So this Greek letter is called chi-square. That is equals to the sum of observed minus expected square divided by expected. Okay, so this one we got approximately equals to 40.620, right? I like 3 decimal places for the test statistic. So in detail, so the first one, so you will looking at the A, you are looking at the 150 observed frequency and the expected 115. So you will be taking 150 minus 115 square divided by 115. And then plus 190 minus 170 square divided by 170. And then plus 100 minus 100 square divided by 100. And then plus 40 minus 65 square divided by 65. And then plus 20 minus 50 square divided by 50. You take the observed minus expected, square the difference to avoid negative, and then you divide it by expected. So the sum of these 5 fractions gives you 40.620, and then the p-value. So according to the screenshot, the p-value is 3.22, so approximately equals to 3.22 times 10 to the negative 8. This is a scientific notation. When you see this, that means the p-value is extremely small. It's very close to 0. So that is less than the alpha, 5%. Look at the top on your right side, 5% alpha, right? So this is less than any alpha, 5% alpha. What does that mean? That means you reject the null hypothesis and the alternative hypothesis is true, right? So let's state the conclusion. So that means we reject H0 and then the alternative hypothesis is true. So that means the observed gray frequency, fit the expected gray frequency. You are trying a pair of shoes. The conclusion is that fits, right? I mean, that do not fit, huh? I wrote do not fit, but I wrote fit. Okay, let's add this back. Do not fit. Okay, do not fit. All right. Okay, do not fit. So the expected, the observed do not fit the expected. And then how do you calculate the p-value without using the chi-square GOF test? So here is how we do it. So that brings you to the next set of screenshot. You will have to click second and then you click vars. Oh, by the way, before we get into the p-value, do you see that there is a graph? So chi-square goodness of fit is a right-sided test. So on the graph, you see that they give you the chi-square on the bottom, so that is 40.6205, so that is where the cutoff is, and then the p-value is so tiny that is on the right hand side. So the 40.6205 is so big, so since that is so big, you would just have to place this cut so far to the right, and then there is only a tiny little piece of p-value on the right hand side of the cut. So that's why when the chi-square is big, the p-value is very small. Another way to think about this is I just say do not fit, right? What does do not fit mean? Do not fit means the observed and the expected, they are not the same, right? So here is another way to interpret that. So let me change to a different color. I'm going to give you an example. So let's say the observed is 1, the expected is 20. Observed is 1, expected is 20. There is a big difference between them, right? So once you take the 1 minus 20, you will get negative 19. You square a negative 19. That makes the product really, really big. And then you divide it by 20, that will just make the quotient remains big. And imagine you have 5 of this added together. You have 5 big quotients added together. Of course, you will get a large chi-square, right? You will get a large chi-square. So when you do the graph, the large chi-square will place all the way to the right, such that you will get a very tiny p-value. So that's the concept. So go back to look at the data, 1 and 20. Can you say 1 fits to the 20? Of course not, right? There is a big difference between 1 and 20. You cannot just say 1 fits the 20. So that's the concept of not fit. Okay, now go back to the p-value. So moving on to the last set of screenshot, you click second and then you click vars. You will see that there is a chi-square CDF. CDF stands for cumulative density function. So cumulative density function, that means the area under the curve. PDF is finding a point on the curve. So CDF means you are looking for the area, and then you click enter, and then they will show you a menu. The lower cutoff is the chi-square statistics, 40.620, and then the upper cutoff I use 1 times 10 raised to the 99. So to type that, you type a 1 first, and then you type second, you type a comma, you type a 99. So take a look on your calculator. Above the comma, there is a double E, right? So the double E is a base 10. So just type second comma to reach to the double E. And then the degree of freedom, 5 letter grade minus 1. Once you click the paste, the command will show up on the home screen. Click enter again to get the p-value. In some calculator, when you click chi-square CDF, they will just display the chi-square CDF on the home screen. So don't panic, just type these 3 numbers in this order and then separate them by a comma. So that is how you get the p-value without using the test function. Okay, so that is the end of this video. If you like it, you enjoy it, give me a like, share, and subscribe, and I will see you all in the next example. Signing out.